The 20th question, for any natural number n, 6 raised to n ends with the digit 0, 6, 3, 2. For any natural number, so n is equal to 1, 2, 3, 4, etc. Let's take n is equal to 1. Then 6 raised to n becomes 6 raised to 1, that is equal to 6. For n is equal to 2, 6 raised to n becomes 6 raised to 2, that is 6 into 6, 36. Next, n is equal to 3. So 6 raised to 3 is equal to 36 into 6, that is also 216, n with 6. So for any natural number n, the number ends with 6. So option B. The question 21, the LCM of 960 and 240 is option A 960, B 240, and C 60, D for 15. So we can factorize 960, we get 480, again by 2 we get 240. That is the second number, 240. So 240 multiplied by 2 into 2 is equal to 960, that is 240 is multiplied by 4 is equal to 960. So we can say that 960, the larger number, will be the LCM of the number if in two numbers one is a multiple of other number, then the larger number will be the LCM of the numbers. So here 960 is the large number, and it is a multiple, it is a multiple of 240, the second number. So we can say that 960 is the LCM, or we can do in another way, the proper way, that 240 again by 2 we get 120, again by 2 we get 60, by 2 30, by 2 15, by 3 5. So the factorization of 960 is to the power 6 into 3 into 5. For 240 we get to the power 4 into 3 into 5. So LCM is equal to, here these two factors are common, and in 2 raised to 6 and 2 raised to 4 we take 2 raised to 6 multiplied by 3 multiplied by 5, which is the number 960. Question number 22. The natural number 1 is a prime number, a composite number, prime as well as composite, neither prime nor composite. A prime number is a natural number greater than 1 that has exactly two distinct factors, 1 and itself. So in 1, there is no distinct factors, 1 and itself. So it is not a prime number. A composite number has more than two distinct factors, more than two factors. So it is not a composite number. Since the number 1 has only one factor itself, it does not fit either definition of prime or composite. So the option D is the answer, neither prime nor composite. 23. For any natural number n, 5 raised to n ends with the digit 0, 5, 3, 2. So for n is equal to 1, 5 raised to 1 is equal to 5. For n is equal to 2, 5 raised to 2 is equal to 25. 4n is equal to 3, 5 raised to 3 is equal to 125. 4n is equal to 4, 5 raised to 4 is equal to 625. So the numbers end with the digit 5. So the answer is B. Question number 24. 3 into 11 into 13 plus 3 is a prime number divisible by 13, a composite number, and odd number. So multiply the numbers 3 into 11 into 13, that is 33 into 13, that is 99, 33, that is 9, 429 plus 3 is equal to 432. 432 can be divided by 2 since it ends with a 2. We get 2, 1, 6. Again divided by 2 we get 108. By 2 we get 54. By 2 we get 27. By 3 we get 9, and by 3 we get 3. So it can be written as 2 to the power 4 into 3 to the power 3. So this number is a composite number. Therefore, the number has more than two factors. Hence, it is a composite number. Question number 25. Assertion A. Root 3 plus root 5 is an irrational number. Reason R. Sum of any two irrational numbers is always irrational. Option A. Both assertion A and reason R are true, and reason R is the correct explanation of the assertion A. Option B. Both assertion A and reason R are true, but reason R is not the correct explanation of the assertion A. Option C. Assertion A is true, but reason R is false. Option D. Assertion A is false, but reason R is true. Let's check the assertion and the reasons. Root 3 plus root 5, sum of any two rational numbers is irrational. It is true. So assertion A is true. Now check reason R. Sum of any two irrational numbers is always irrational, which is not true because 2 plus root 3 is an irrational number. 2 minus root 3 is also an irrational number. But 2 plus root 3 plus 2 minus root 3 is equal to 2 plus root 3 plus 2 minus root 3. It can be cancelled. So the answer is 4, which is a rational number. Therefore, sum of irrationals is not equal to irrational for some cases. Therefore, reason R is not true, but assertion is true. So the answer C is correct. Question number 26. If the HCF of 210 and 55 is expressed as 210 into 5 plus 55m, Then find the value of m. Here HCF of 210 55 is given as 210 into 5 plus 55m. Seven. Find the greatest number less than 10,000, which is exactly divisible by 48, 60, and 65. Exactly divisible by these numbers means we have to find LCM of the numbers.
Factorize the numbers. 48 can be written as 2 into 24, and 24 can be written as 2 into 12, and 12 can be written as 2 into 6, and 6 can be written as 2 into 3. So the factors are 2 the power of 4 and 3. Next, for 60 we can write 2 by 2 we get 30, by 2 we get 15, and by 3 we get 5. So the factorization of 60 is to the power 2 into 3 into 5. 65 can be divided by 5, we get 13. 13 is a prime number. So the prime factorization of 65 is 5 into 13. Now the LCM of 48, 60 and 65 is, there are total 2, 3, 5, 13. 3 factors are there, and its highest factors for 2 is 4, and for 3 is 1, and for 5 is 1, and for 13 is 1. So the LCM of 48, 60, 65 is to the power 4, that is 16, multiplied by 3 into 5 into 13, that is equal to, the value of the multiplication is 6120, and we have to find exactly divisible by by these numbers which is less than 10,000. So we have to find the multiple of the LCM which should be less than 10,000. So we can divide 10,000 by 3,120. Then we get how many times we can multiply 3,120 to get less than 10,000. So 3 is the number. So we can multiply 3,120 by 3. Though, so we get 9,360, which is the greatest number, exactly divisible by 48, 60, and 65, and less than 10,000.